it. All right. We now I would like to show the homework here at the check. So far, it only the first two, so these two unquestionably put them in the chat. All right, so these.
So let me maybe snip, do just one at a time. Okay, let me. Okay. So it says to graph y equals 2x plus 3, but only for x greater than or equal to -4. So one of the ways I'd like to show this to students is in a table here, x and y, and you always start at the place that it's kind of the boundary or the edge condition. So you say at -4, but you make some note that it's an open circle there. Do you know what I mean by that?
Yeah, so it doesn't
And
include the.
yeah, so it's because of that symbol there. And then you're getting larger than -4, so -3, -2. Your instructor may have specified how many points they want on a line. You only need 2, but sometimes they want you to plot more than 2 points. So you put those, so I want you to put those numbers, -4, -3, -2 in for x here. Give me the result, please.
Right, so the first. Got -5
Okay.
for -4, so for -3 it'd be -3 again because it's -6 plus 3. And for -2, that'd be -1.
Okay, so -4, -5. What you do again is it's an open circle there. So you go to the graph. I guess I'm going to do it in red just so it stands out a little bit more. -4, -5. You put an open circle there. Okay. Then the rest of them are going to be filled in. So -3, -3, -2, -1. And then it's up to you if you feel like you got to be careful. Like you're not. Depends how accurate your instructor wants your graph to be. And so maybe look at your notes and see how many points did they draw.
I think it's just like if it's only one boundaries and it's not like x is greater than or equal to -3, but also less than 10. If it's not like that, then I think she just wants it to be like following like the slope of up all the way to like so like pretty much for the rest of the line. That's pretty much what she's expecting. What we did in the notes, basically.
So you follow that. I mean, if you need to put a few more points in, please do. Okay. Now the domain and range, the domain actually comes from this part right here. All right. So the domain is and are you guys using set builder or interval notation?
interval notation, but
Okay.
she accepts the other set boundary one, but
Okay.
interval notation.
So the set builder, or sorry, the interval notation is preferred here. It's -4 to infinity. There's some like things that,
When I did it, I got bracket -4 comma parentheses comma infinity parentheses.
yeah, so these symbols here go with these symbols, and then when these symbols filled in dots go with brackets, and then infinities are always going to go with parentheses.
Got it.
So in this case, like sometimes what it's better to do is draw a number line for the domain. And say, okay, it's from -4 to infinity, open circle everything to the right. And so you bound those with parentheses, and then it's -4 to infinity.
All right. And so for the range, I got parentheses -5 comma parentheses comma infinity parentheses with the correction of like the parentheses.
Yeah, and that's good. Now domain, we can use some words here that I think could be helpful here. It's left to right. For range, it's min to max. Min to max.
Got it.
Sometimes students prefer a bottom to top, and it could be brackets as well, could be parentheses, depends on.
All right. So
All right, so
for
let's look at number two.
yeah, for number two.
Do you want to try doing number two on your own, or do you want me to jump in and show you how
So
to do it?
what I did when I got it was yeah, I used the x since its x is less than 1. So yeah, it'd be open. And
Right,
then
and you got to pick values less than
it would be I got -10 for 1.
I'm sorry, which one?
For x is 1, it'd be -10. Y is
Good. Yep.
-10.
Yep. Good. Keep going.
Um, for 0, it would just be -7.
Okay.
And for -1, it'd be -4.
Okay. Good. So when you graph that, I'll do that in red here. 1, -10. Open circle, 0, -7. One of the reasons I was asking about how many points to plot is like sometimes these things like make sure you plot the y-intercept and the x-intercept. And if we don't
For
have all of
us,
those.
she wants us to plot like the y-intercept if it falls within like that range. Like if it's in the range, then she wants us to plot like the y-intercept. That makes sense, but
So this looks something like that. Make sure you get that arrow there.
Yeah, then for the domain, I got parentheses negative infinity, comma 1 parentheses.
Okay, negative infinity, comma 1, good. And then the range,
Parentheses negative 10, comma positive infinity parentheses.
right,
Yeah.
good.
All right.
All right, good job.
All right, next one.
Hey, why don't you try this one on your own unless you already have, and then I can graph it here. You need me to graph this, Karthik, or are you working on it? I'm sorry, I just didn't know where you were.
Yeah, I'm graphing it right now.
Okay.
All right, I got a domain. Sorry, first I graphed it.
Okay,
Close circle at like 10 or negative 1, 10, and then going down 4 over, down 4,
right,
right 1, all the way down, and then um, the domain that I got was bracket negative 1, comma positive infinity parentheses,
good.
and then parentheses negative infinity, comma 10 bracket.
You got it, good. So it's really easy to miss brackets and parentheses. I would double check that, on your test, like really make sure.
And
you have to graph any piecewise graphs with more than one piece?
We did have us like kind of practice that in class, and I think there are. Yeah, there are some. Like for example, little here. But here. Uh, so this is another type of question. Here, here. So we have 3 questions here. So it's kind of like a filling in like the right part of the piecewise function. There's the
So. All right, so number one here, we'll start with number one. So what you wanna do here is visualize the 3 sort of breaks in the graph. There's these natural breaks here. You can sort of see it here at 3. There's another one at 2. Okay. So the thing that this graph doesn't have that it should is it should have arrows there like that. I presume it goes on forever. Although you might ask your teacher, but it does look like it goes on forever. So the first one here, for 2x plus 7, for this line here in the left region, it's kind of this left window, it's x less than -3. The reason it's less than is because of the open bubble. So again, open bubble goes with less than, open bubble goes with greater than, filled in 1, less than or equal to, filled in 1, greater than or equal to, like that. So then this middle one is the hardest because it's a between case.
Yeah, so it'd be like x is, yeah, so it'd be like x is greater than or equal to and less than or equal to.
Yeah.
And then the last one would be like the first one, but it'd be opposite. It would
It's
be x is
x
greater than
2, yeah.
2. Got it. So then the next question, number 2 there.
Why don't you fill in the last part there in number 2, where it's the last interval? Tell me what goes here, please.
So we did go over like an example like this one in class. Of course, we haven't went over
Just
like the
right,
graph
but
type, but
we'll do the equations in a bit. But just what do you
yeah,
what
for the
like
last
what goes
one.
here? Do the easy stuff first.
X is greater than or equal to 2.
Okay, good. All right, now in the kind of these positions here that we're going to fill in, you need to recognize like what is it like and your options are okay, is it a line, is it a quadratic, is it an absolute value? Like it could be anything, it could be a straight line, or I'm sorry, it could be a horizontal line. So in this first one here, you you kind of got your work cut out for you. It's boy, they didn't make this one very easy on you. You want to write, it's a line, so it's got the form mx plus b. Okay, so the slope is kind of kind of doable here. Usually they give you ones that are nicer, like where they fall on you know, the grid intersection of the grid. But this one's got a rise of 1 and a run of 1. And like, I would prefer like nice gridded points, but you don't have them here, unfortunately. Like, it's not like it falls on these intersections of, of the grids. So, but that's enough to figure out the slope. The slope is 1. And then the B value, to get the B value, really what you do is you actually extend the line to where you think it hits, typically is the best way. Gives you a rough estimate, unless it's something weird, but it looks like the B value here is, 3, -3, sorry. So the B value is -3. So it becomes 1x minus 3, and that's in its first position.
Got it.
So why don't you try writing the equation for the middle one for this line right here? Let me know when you've got the equation of the line here.
I think it's 1/2 x plus 1.
Okay, your slope is the issue here. Because you're going, it's rise over run.
So I think yeah, so do 2/1.
Well, it looks like it's actually going up 3. Like, think of that as 1, so 3 up and then 1 to the right.
Oh, got it.
So 3x plus 1.
Yeah, I think it was just a little bit harder to get. to gauge because it wasn't directly on like the point.
So that would go in that next position like that.
All right. Number 3 is relative. Right, it's not. Right, the first one, uh,
All right, so the next thing here is and I would always do the intervals first because I think they're easier.
yeah.
Like
So
sometimes you get like points for doing the right thing.
yeah. So for the first one, I got x is less than or equal to -4.
X less than or equal to -4 like that. How about the one on the right?
X is greater than or equal to 3.
Good. Now, this is a, quick thing here. Horizontal lines are always y equals a number. And then vertical lines, which you won't see in this context, but you might see in another, is x equals a number.
Got it. So of course the x is like it's vertically on only that.
Yeah, and this is something you got to remember for the rest of your math, class. You just like, you don't want to be confusing these.
So then in that case, the middle one would be 2.
It's just the y value.
All right. So, I did a problem like this one in class. That was part of our notes, but when I put still wasn't completely sure how to do it, so I put it in the chat. So there's the entire word problem. There's a couple parts to it.
Let me, so let's snip it in pieces here. All right, so Verizon offers a data plan to share data with family. If you choose the 10 gigabyte plan with 4 shared devices, then the base price is $140 for the first 10 gigabytes, and each additional 1 gigabyte of data will cost $15. So actually, the first thing here is to write. I think it's really to write the piecewise function, which is C. For some reason, they don't have you do that first, but I think that's actually the better. Uh, better one. So let's actually do that first. Okay. So For the first 10 gigabytes, like it doesn't matter whether you use, 0 or all the way up to 10 gigabytes. The cost is $140. I think most of us have unlimited data now.
X equals 40, just X is greater than
Does that make sense, or is that just
yeah, I think it makes sense because
okay?
you can't be charged for like negative. Um,
Right, yeah, exactly.
got it. And then
Then what happens? Well, if you wanna get more than 10 gigabytes of data, it costs you $15. So it's the base price plus 15 times the gigabytes.
yeah, in class she had us do like we had a similar problem where for example, instead of 140 for the first 15, or it was for the first 15 gigabytes, um, it was 160 for the first 15 gigabytes of data. Same kind of problem. And we first found like we first found the piecewise function where we did 160 comma is 0 is less than or equal to x, which is less than or equal to 15. And then she has to 160 plus 10 times x minus 15 because you're not charged.
So that's what I was
Uh,
about to say. That's what I'm
yeah.
about to go to is like the problem is that these don't equal the same thing at 10. At
Yeah, that's
10,
what I thought at first.
yeah.
We were doing the notes that you're supposed to just do the y equals mx plus
So
b.
so you always subtract the
God, I
the
see what then
that thing there. Yeah. That
the
edge point.
cost per God. So then in this case that would be minus 10. So 140 plus 10. So now that we have the piecewise.
So that's your piecewise function. Then you want to make sure you put the f of x over here. Usually there's an equal sign. You got to give the right notation
In this
for
case, wouldn't it be p of x?
is that what they want? Yeah. They want p of x. Yeah. So you got to use the letters they want.
Yeah, because I remember she saying that in the last test that we took, some people put like f of x for one of the problems and it said h of l to use, but she didn't take our points for that, but she wanted it to be like in the way that the problem kind of states it, which in this case would be like p as a
You, you,
function of
you
x.
should do exactly what they want. Don't
Yeah. All right. Let's see. 8A, what is the cost of your service if we use 8 gigabytes of data?
this is now part A, 8A is like what we were doing earlier, which is you have to decide is 8 now between 0 and 10. Like, does it fall in the first interval, first piece?
So wait,
Is 8
4,
between 0 and 10?
8, yeah. So
So you use the first one. You put it's the
so it's
cost is
140. So
is
P of
140.
1, Then what is the cost of your, this is E. What is the cost of your service if you use 12 gigabytes of data?
Yeah, so you first check, well, is 12 between 0 and 10? The answer is no. So is 12 greater than 10? Yes. So use that second one.
So P of 12 equals 140 plus 15 times 12 minus 10. 20, 180. Minus P of 12. I got 170.
Okay.
The P of 12 is $170. P of 8 is $4. So then, yeah, then D is just evaluating which kind of
Yeah, I
is
mean,
it the
it's weird that their A and B are the same and
yeah, I
B
think
and
A
E.
and B is like you're supposed to like kind of use just the numbers and kind of estimate it,
Yeah.
I guess. I don't know, but it kind of seems like the same thing. Anyways, yeah, should be the same as yeah. Mm, all right, so I guess that's how you would kind of do this type of word problem.
But a few minutes left here. If you've got, another question we can look at.
Um, I do have this one. Right. All right, so I do have a question on this. We're going back to
So let's, I
so
mean, these are all good to do.
in specific, like the middle one.
Yeah, let's do the middle one first. So the middle one says to first do f of -1. You always start with the inside function. So f of x is here. Now, one of the things that students don't do that they really should do is they should treat the variable as if it's in parentheses. Like this. Because when you substitute in -1, you're substituting in just for the variable, and it's easy to miss the sign here out in front. So this is -1 squared with f of -1 plus 2 times -1 minus 3. So -1 squared is 1. Negative of 1 is -1 minus 2 minus 3. So that's part 1 of that. This thing with the parentheses is really super important, so please don't miss that. Make sure you're substituting in parentheses.
Got it.
Okay. The next thing is now whatever you're done with that, then you take g. So whatever that result is, you're going to take g of -6 because your result of -1 is -6. So you're finding g of -6 now. G of x. Let me write it. Again, it's good to write it as it in parentheses. It's 4 times x minus 11. 4 times -6 minus 11, like that.
All right. Yeah, I got g of -6 equals -35.
Yeah, and you got it. Alright, so we can do 9 or 7 real quick. Do you have a preference?
We can go ahead and do 9.
9, okay. So 9 is G of A plus 2.5. So what's maybe frustrating or different about this one is that it's not a number. Yeah, you're finding G of 9, G of 2A plus 5. And what that means is you're putting 2A plus 5 in for X. So instead of X, you're putting in 2A plus 5 in for X.
In this case, we would be solving for
You're simplifying. Solving
uh,
is when there's an equal sign, you're gonna distribute this in here. 8A plus 20 minus 11, 8A plus 9, like that. All right, I just stop there.